Welcome to Chapter 5. This first section is 5.1 and it's slope. Go ahead and put today's date up in the top right hand corner. And the target for this lesson is that I can find slope of a line on a graph and given ordered pairs. So first off, we're just going to get the definition of slope so we can remember it. Slope is the steepness of a line described by a number determined by 2 points on the line. Okay, and then once we remember slope is the steepness of a line, it's also our variable m. So slope is often seen as our variable m. And now to just refresh us about slope, if slope is the steepness of a line, that means we're going to have to look at it as also being a rate of change. For especially in word problems, we're going to refer to it as the rate of change. So slope being the steepness of a line, actual real world situation of a graph is going to be referred to as the rate of change. Now slope is found by saying it's our rise over our run. If you think about rise, it's on our y-axis. So rise is your change in y over your run, and your run is on your x-axis, so it's your change in x. So if you're given a set of ordered pairs, we use our slope formula y2 minus y1 over x2 minus x1. Okay, now when it comes to actually writing slope for our answer, there's a couple of things we need to remember. We have to write our answer as an integer, and remember integers are all whole numbers and their opposites, or a fraction. And that's the only way we can write our answers for slope is just as an integer or a fraction only. And if we do have a fraction, then we need to make sure that we reduce our fractions. We want them in their simplest form. Okay, so some real world examples of slope that we see are like a roof, because if we look at the side of the roof, it has a slope because it's showing how steep the roof is. So it says the units of the roof are 8 feet and 12 feet for the run. So they put where it rises 8 feet, so rise is 8, the run, so the run is 12, so they put that on the bottom, and then they reduced it. 8 over 12 is 2 over 3. And roofs are always a very good example of showing slope because you can see it right there, the steepness of the roof. Where it's like if someone lives in an A-frame house, the steepness of their roof would be much steeper than this one. So that kind of shows the steepness of the different roofs and why we need slope. Okay? And also if you refer to like ramps or anything of that sort, some ramps are steeper than others. Once again, it goes back to the slope, the rise over the run. So this just shows basically what we copy down. It's describing slope as the rise over the run. So they started with this point right here, and they showed it went up 1, 2. So the rise was 2, and it ran 1, 2, 3. So over 3. It also did it by using the x and y values. So remember, rise goes on top, so your y's, rise is y. It kind of rhymes. So 5 minus 3. 5 minus 3 is 2. And then 4 minus 1. 4 minus 1 is 3. So 2 over 3. So that shows you how it works on the actual graph and with the ordered pairs. So let's do some of these ourselves. But before we get into the examples, we need to go over the 4 different types of slope. And our first slope is a positive slope, and it goes up and to the right. And just make a quick sketch of these, that way you can kind of get the visual of what type of slope it is. So positive slope goes up and to the right. Negative slope goes down to the right. And if you notice, one thing is that they're both going right. up and right and down and right. That's because if you go down and left, you're back to being a positive slope because it's like two negatives make a positive. So for your positive and negative slopes, it all refers to the right, up and right, down and right. Now our slope of 0 is a horizontal line, and it's for like if we get a line that says y equals 2, because it just has a y, so it's just going to go through your y-axis at 2, y-axis at 2, and then it's a horizontal line, because if you all remember from doing these with the table, your y value is always 2, so y is 2, y is 2. Also, if you're finding slope, if you end up with something like m equals 0 over 5, you always reduce it and say, how many times can 5 go into 0? 0 times. So slope of 0. Then our last one is an undefined slope. An undefined slope is a vertical line, and it's for like when x equals 3, because that means it's going to go through your x-axis right here at 3, and it's going to be a vertical line because that's cut through your x-axis. Also, if you're solving for slope, it's going to look like this, m equals 5 over 0, and that's going to give us an error, especially if you put it in your calculator, 5 divided by 0, because 0 cannot go into 5. Anytime 0 is on the bottom, it's going to give you an error. That means it's an undefined slope. So now that we've seen our 4 types, we've seen an example already done for us. Now let's get into our example. So example 1, it asks us to find the slope of a line that passes through negative 1, 2, and 3, 4. Okay, so whenever we see our 2 ordered pairs, we're automatically going to know that since it's not a graph, we're going to have to use our slope formula. So m equals y2 minus y1 over x2 minus x1. So then we're going to come up here to our ordered pairs and label them x1 because it's our first x value, and y1 because it's our first y, then x2, y2. And then we're just going to plug in our values. y2 is 4 minus y1 is 2 over x2 is 3 minus x1 is negative 1. So we know minus a negative is going to give us plus a positive. 4 minus 2 is 2 over 3 plus 1 is 4. We see if it can reduce, and 2 over 4 is 1/2. Okay, so that means that the slope for a line that passes through the point negative 1, 2, and 3, 4 has a slope of 1/2. So let's look at one more example where we're given ordered pairs. So our second example says the slope of the line that passes through 1, negative 2, and 1, 3. Okay, so we're going to write our formula. M equals y2 minus y1 over x2 minus x1. Then we're going to label our ordered pairs. So x comes first, and this is our first one, so x1, then y1, x2, and y2. Now, just go substitute in. y2 is 3, minus y1 is a negative 2, over x2 is 1, minus x1 is 1. So as soon as we see minus a negative, we know that's plus a positive. And 3 plus 2 is 5, over 1 minus 1 is 0. Alright, now this is where you can either go to your calculator and try 5 divided by 0, and your calculator gives you an error message, or you can go and look back to your notes about slope and say if 0 is on the bottom, it's an undefined slope. So all we're going to do is write U and D. Remember, anytime your calculator tells you error, it's going to be an undefined slope, and that's all we have to write. So that means that the line that goes through 1, negative 2, and 1, 3 is a vertical line. And like I said, you can just go back here and look at your notes and say undefined means it's a vertical line. Alright, so our first two examples dealt with the actual formula. Our next examples we're going to look at is going to be a graph. So for example 3, go ahead and sketch out the graph. It goes through -4, 0, and our other points at 0, 3. Now to find the slope of a line that's on a graph, we're going to use our rise over run formula. So rise over run. Now to find the slope of a line when it's graphed, we're going to start the same way we read. We read left to right, so we're going to find the slope left to right. So we start with the ordered pair on the left, and I have to figure out how many I have to rise, or how many I have to go up to get to our next point. So I go up 1, 2, 3. I go up 3, and that makes me even with it. So my rise is 3. Over, and I see how many I have to run. So I go back to like where I left, and from here I say I run 1, 2, 3, 4. So 3 over 4, that's a fraction. It can't reduce because 4 can't go into 3 evenly. And that's all we have to do. The big thing with this example is to remember to find slope from left to right, the same way you read. And then you can always go back and check. This line's going up and to the right, so that must mean it's a positive slope. So we look over here what we got, and it is also a positive slope. So we're good. So let's look at our last example. It's another graph. So example 4. Once again, for an actual graph of our line, we want to use our rise over run formula. M equals rise over run. And we're going to look at these ordered pairs then. This ordered pair, that's our first one on the left, is 0, 2. And our next one down here is 1, 0. So now, I'm going to have to look at this left point. To get to the right point, I have to go down. And because I have to go down to it, that's going to make my rise a negative number. So I go down 1, 2. So my rise is a negative 2 because I went down. Over. Now my run, so I go back to where I left off, and I run 1. So my run is 1. Then we see if it can reduce. So negative 2 divided by 1 is negative 2. And remember, we always want it in simplest form. And you can go back and double check. This line goes down to the right. So that means it's a negative slope. It shows right here negative 2, so our slope is negative, so we're good. And once again, be sure whenever you find slope that you're looking left to right. And you kind of make this triangle shape when you go down and you go right. So, same thing with our other one when we went up and right. You kind of make a triangle with the line. And that concludes our slope video lesson. Hopefully now you can find slope from ordered pairs and a graph. Thank you.
Okay, now for example 5. Our instructions change gears on us for this one. It says find the value of r so that the line passes through each pair of points has the given slope. So we're given this ordered pair here, which is 6, negative 2, and then r is our missing coordinate in this ordered pair. So we have r, negative 6, and it tells us this time our slope is 4. So it gives me 2 ordered pairs and tells me that the slope is 4. So anytime we're given 2 ordered pairs written out like this, we're going to use our slope formula. So m equals y2 minus y1 over x2 minus x1. And now remember, in our ordered pairs here, we'll have our x1, y1, because it's the first order pair, so x and y. Then we'll have our x2, y2. And now it's good old-fashioned substitution. What makes this one different than the first examples we saw is this time I know what our slope is. M is 4, so I'm going to have to replace m here with 4. Equals y2 is negative 6 minus y1 is negative 2. So once again we have minus a negative, it's just going to make it plus a positive, over x2 is r minus x1, so x1 is 6. Now because this side over here is a fraction, I'm going to write my left side like a fraction as well. So it'll be 4 over 1. And now let's reduce it. So 4 over 1 can't reduce, so it just drops down. 4 over 1 equals. Now negative 6 plus 2 will give me negative 4. And for this denominator, I have r minus 6. They are not like terms. He is an r, he's a number, he's our constant. They cannot be combined, so it just stays r minus 6. And now at this step, we have a fraction set equal to a fraction. So we're going to use cross multiplication. So we're going to find the cross products to solve out this equation now for our missing coordinate. Alright, so we have our first part will be 4 times r minus 6. If you remember back in Unit 2, because he has two terms there, it'll stay in parentheses, so 4 times r minus 6 equals. And now my second part will be negative 4 times 1. And remember, equal sign always drops down, so don't forget your equal sign here. Negative 4 times 1 will be our next part, and we're good. So now, to solve the equation, we're going to have to first distribute. 4 times r is 4r. 4 times negative 6 is negative 24. Equals negative 4 times 1 is negative 4. And now we keep solving for r. So we're going to transpose our minus 24. So our 4r drops down, equals negative 4 plus our 24. His sign changed. Negative 4 plus 24 will give me 20. So 4r equals 20. Divide both sides by 4. And r equals 5. There we go. So we have now, we'll extend the page real quick, found that missing value of r in this order pair. So in order to go through this point and now to go through the order pair 5, negative 6 with a slope of 4, that coordinate right there needed to be the 5. Okay, and that's what we do to find the missing value of an order pair. So now, let's see one more to make sure we're all good to go with it. So example 6, we have 9r, and then we have 6, 3, and it gives us m equals negative 1/3. So it goes ahead and gives us our slope again, so we can find this missing value of that order pair. So, first things first, it gives me two order pairs and a slope, so I can use my slope formula. M equals y2 minus y1 over x2 minus x1. My slope here is negative 1/3, and that negative symbol, I always give it to the numerator because it only goes with one of them. You can either go with just the top or just the bottom, but not both, because a negative and a negative makes it a positive, so you gotta just give it to the one of them, and I always just go with the top. So I'm going to have a negative 1/3 for my m equals, now we got to do our x1, y1 for our first order pair, x2, y2 for our second order pair, and substitute. So y2 is 3 minus y1 is r over x2 is 6 minus x1 is 9. Now we want to reduce it, so negative 1/3 can't reduce, so it just drops down, negative 1/3 equals 3 minus r cannot reduce because he's a number and he's a variable, not like terms. And now lastly, 6 minus 9, I can do that. That gives me negative 3. And now we're all ready for those cross products. Alright, so I always like to do my binomial first because it has two terms in it. So I'm going to do 3 times 3 minus r. So 3 times 3 minus r. Remember to drop down that equal sign, so equal to. And now we have a negative 1 times a negative 3. Alright. For this equation, first thing we've got to do is distribute. 3 times 3 is 9. 3 times negative r is negative 3r. Equals negative 1 times negative 3 is positive 3. Now let's go through our steps for solving the equations. So it's back to Unit 2 again. We're going to transpose our 9. So we drop down our negative 3r. Always keep that sign in front. Equals 3. And because he's positive 9, he's now a minus 9. We get negative 3r equals 3 minus 9 is a negative 6. Last step to solve for r is divide both sides by negative 3. Negative 3. Negative 3's cancel, and r equals negative 6 divided by negative 3 is going to be a positive 2. And we have that missing value now for our second coordinate. So now, in order for it to have a slope of a negative 1/3, you'd have to go through 9-2 to then also go through the point 6-3. And that finishes up for these type of examples. So as far as it goes, take a second and just kind of look over them, make sure we're all good, because we're going to change gears one more time. Okay, so now for example 7, we're given new instructions. There's lots of things we do with slope where it's our constant variation and our rate of change. So first things first, read your instructions. It says, without graphing, tell whether the slope of a line that models each linear relationship is positive, negative, 0, or undefined. So our 4 different types of slope. Then find the slope. So for this example, we're told that a cost of a pair of jeans is $22.50 for one pair and $67.50 for 3 pairs. So because it went up from $22.50 to $67.50 because we bought more pairs of pants, it's going to have a positive slope. And it also asked us to find this, oh, it came with me, there we go, it also asked us to find the slope. So what we're going to have to do is turn this data into a set of ordered pairs. So real quick, you kind of have to think about what your x and y's are in your ordered pair, because you have an x and a y. So x is our independent variable, and what that means is he is what we can control. So it kind of goes back to science for a second. He's the independent variable, or the one that we can control. Y is our dependent variable, and he's the one that's being affected. So whatever we choose to do with x, like either buy 1 pair of pants or to buy 3 pairs of pants, that's what is independent. And then y, the price of the pants, changes for the number of pairs we buy. So we're going to write these like ordered pairs now. So my first one will be 1 and then $22.50. And my second one will be 3 and $67.50. And now we're right back to where we were with our first couple of examples, where if I'm given 2 ordered pairs, we're going to use our slope formula to find the slope. y2 minus y1 over x2 minus x1. We know our first ordered pair is going to have x1, y1, x2, y2. And now we're good. We just substitute. There we go. So m equals y2 is $67.50 over minus, got a little ahead of myself there, minus our y1 is $22.50. Our x2 is 3 minus our x1 is 1. Now we're good. So $67.50 minus $22.50 is going to give us 45. There we go. 3 minus 1 is 2. And now we divide that. So 45 divided by 2 gives us 22.5. If you think about money, because this dealt with how much money it was, that would be like $22.50 per pair of pants, and that's what it had in the beginning. So the slope for this one is just 22.5, because it's going to increase 22.5 or $22.50 for every pair of pants you buy. All right, now one last example, example 8. Alright, so for this one, we're given some more data. So it's a lot like the last one we just did, except this time we're getting a little bit of reading and a graph. So it says find the rate of change. So remember, rate of change is another name for slope. For 1990 to 1992. Without calculating, find the 2-year, okay, so that's the first one, and this will be our second one. And then without calculating, find a 2-year period that had the greater rate of change than 1990 to 1992 and explain your reasoning. So once again, very first thing we've got to do to find the rate of change is to take this graph and turn it into a set of ordered pairs. So this goes back to what we talked about before about x being your independent and y being your dependent. So x being the independent means what is controlled or what is going to be consistent and keep going. And then y is your dependent, which means it is affected by the other one. So it says U.S. cable TV subscribers. So, because this is our x-axis, it means this is our independent variables. But also, if you think about it, year is something that cannot be affected by anything. Time's going to keep on going. So that's why time will always be down here on your x-axis, because it's our independent. So our first one for 1990, so we can put 1990, and then find that y value of the number of people who subscribe to cable TV. It says it's 52. Alright, we're going to do the same thing for our next one. So 1992. So 92 is our year, which means it's our independent. And then how many people subscribe to cable TV, and that would be our 55. Because the amount of people who subscribe to cable TV changed each year. So that's our dependent. Now, we have our two order pairs. So as always, to find our rate of change or to find our slope, we're going to use our x1, y1, x2, y2, and our slope formula. ELM equals y2 minus y1 over x2 minus x1. And now we substitute. So ELM equals y2. It's going to be 55 minus our y1, which is going to be 52, over our x2 is 92 minus our x1 is 90. Now we're good. So 55 minus 2 is 3. And now 92 minus 90 is 2. As far as that goes, because this is a real world problem, we do want to keep reducing it. So 3 divided by 2 is 1.5. This is one of the only times we can